Okay, so we're going to continue with question 3. So question 3 is still a vertical linear motion. Oops. Okay, but there's a slight difference between the things that we're going to see today and the things that we have seen in a previous lesson. So previously we were discussing, we are talking about you throw something downwards. Okay, you throw something downwards. And today we are going to see what happened, how are we going to solve it if we throw it upwards. All right, so before I before I forgot something. So last week I've made a small mistake here. Okay, so the U should be a negative sign because when you throw something down, the velocity is going down. So you have to take into considerations the negative sign here. Okay, for questions 2. So questions 2, U is equals to negative 8 meter per second. So now today we're going to look at what happened if you throw something upwards rather than you throw it downwards. So an object is thrown vertically upward with an initial velocity u equals to 20 meter per second. Determines the maximum height and the time taken. So let's draw a diagram first. Okay, so this is a ground and this is our object. So now what am I going to do? I'm going to throw it upwards. Okay, throw up. So if I throw it upward, the u is a positive value because it is going up. Okay, so now I have a 20 and this 20 is a positive value, 20 meter per second. So I throw it up and then, okay, the question asks you to determine the maximum height. So let us list down the information that we have first. So u is equals to 20 meter per second, positive value because it's going upward. And then a in a vertical motion is always negative 9.81 ms negative 2. Now we don't have enough information though, because if you look at questions A asks you to determine the maximum height. Height is a distance, okay, it's a displacement. So S is an unknown. Now in order to apply the 4 linear equations, we need 3 known variables and 1 unknown variables. All right, which mean in our questions, there must be some hidden information that we haven't noticed. So let's go back to the questions again. An object is thrown vertically upward with an initial velocity. So this statement, you have only one information, which is u. Now determines the maximum height. So the keyword is maximum. When you throw something up and when it reaches the maximum height, what is going to happen? So at maximum height, our object is stopped for a moment. So at this point, our v would be equals to 0 ms negative 1. All right. So at maximum height, before our object changes its direction, it stopped for a moment. Therefore, we have v equals to 0 ms negative 1. So now, do we have enough information to solve this question? Yes, we do. So we have u, a, s, and v. We need an equations that contain these 4 variables. So the equations that contain these 4 variables is v square equals to u square. Okay, it would come up. Okay. U square plus 2as. And then v that we have is 0. 0 equals to 20 square plus 2, and then a is negative 9.81, and then s. So if you calculate it correct, so s is equals to 20.4 meter. So it is a positive value because the object is above the original position. Okay, the maximum height happens at the place that is above the original position. So let's look at questions 2. Now questions 2, the time taken. So time taken, now this one is easy. The time taken to reach maximum height. So what is the information that we have? Same, we have a u equals to 20 meter per second. And now we have a equals to negative 9.81 ms negative 2. And then the v is equals to 0. Okay, 0 ms negative 1 because it's at maximum height. So by applying equations, okay, now you want to find t. So the equations that contain these 4 variables is v equals to u plus at. Okay, so substitute, okay, you substitute by yourself. and then rearrange the equations, you will get t equals to 2.04 seconds. So this is how you solve the questions. Try to read the questions and then sketch a diagram so that you see what is going on. And from the diagram, you can tell whether the answer is correct or not. So for instance, S, if you got negative value in your calculation, then a diagram shows that maximum height, it happens at above original position, then it means something wrong with your answer. So you can counter check the answer and the diagram, okay, cross check. All right, so that is questions 3. So questions 3, the keywords that I want you to take note is maximum height. So at maximum height, V is equals to 0. So questions 1 tells you V, okay? You yourself have to know it is always equals to 0. So questions 4. An object is thrown upwards. Again, you throw up with a velocity 10 meters per second. What is the final velocity when it reaches the ground? So it's very important, okay? Reaches the ground, it carries a very important information here. And then what is the times of flight? Now let us draw a diagram again. So this is the ground. You throw an object upwards with an initial velocity. So you have u equals to, now going up, positive 10 meters per second. Okay, you throw it up. So this object will keep moving up and then eventually it will reach a maximum height. Okay, and then what happened? It will drops. Okay, it will drops. So it will drops until it goes back to the ground. All right, and at this point, your velocity is heading downwards because the object is dropping. So how are we going to solve this question? There are 2 methods. Okay, let me show you the first method first. Truth calculation. How are we going to know what is the final velocity? First, you can solve it truth calculation. So we are given u equals to 10 meters per second. And then we know this object, it undergoes free fall motion. How do I know? Because the moment you throw something and it leaves your hand, okay, it's moving without any external force, then we say the object undergoes free fall motion. So when an object undergoes free fall motion, A is always equals to negative 9.81 ms, negative 2. Now we have only 2 pieces of information, right? We don't have enough information to apply any of the equation. Let us go back to the diagram. If you look at the diagram, this is the initial position, okay? And then this is the final position. Final and initial, both of them, they are on the ground, okay? They are lying on the same level. So in this case, we can conclude that the displacement between initial and final position is 0 meter. Okay, because they are lying on the ground. Both of them, they start and they end at the same position, same height. So now that you have enough information and you want to calculate V, so how are you going to calculate? UASV, so again, we're going to apply V square equals to U square plus 2AS. Okay, so you have a V square equals to 10 square plus 2 negative 9.81, and then S is 0. So from here, you will get V equals to plus minus 10 ms negative 1. Now, based on the diagram, like I told you just now you throw something, it drops. So at its final position, just before it hits the ground. Okay, so the question is a bit misleading. It says when it reaches the ground. So reaches means it hits the ground already. So that at that moment, the velocity should be 0. But in our calculation, our final velocity will never be equal to 0. All right, we are going to take the moment just right before it hits the ground, just before it changes to 0. Okay, the velocity changes to 0. So therefore, before it hits the ground, the directions of motion, the directions of velocity is still going downwards. Therefore, it should be a negative V. Okay, so your V is negative 10 meters per second. So this is if the question asks you to prove it or you solve it by calculations. All right, because sometimes you might have forgotten what is a concept when you have an object that is located, the initial and the final position that is located at the same level. So in that case, you can solve it by calculation. right? Now, if you know the concept already, okay, if you already know the concept and you think you don't want to do the calculations, what can you do? So you can explain it by using works, because these initial and final positions, when they are located at the same level, we know that they have the same magnitude. The only difference is in terms of the direction. So in that case, what can you say? You can say when s equals to 0, okay, as y, the vertical displacement, equals to 0, means now they are at the same level. So your v and u, okay, v is equals to u in terms of magnitude, okay, in terms of magnitude, but opposite in direction, okay, but opposite in direction. So therefore, v is equals to negative 10 ms negative 1. So for those of you who know the concept, who know what is going on, when an object drops and goes back to the same level as the initial position, then you can straight away explain it by using the sentence. Okay, but this type of question, usually it comes out in objective questions rather than subjective. Okay, so objective because you can answer it immediately without any calculation. By looking at the diagram, you know that v is a negative 10. You don't even have to calculate. All right, so this type of questions usually will comes out in an objective question. Okay, so that is your velocity, final velocity. So don't forget, we have a second part of the question where it asks you to calculate the times of flight. Now, what does it mean by times of flight? Times of flight means the times taken from initial positions to final position. Okay, you don't have to look at what is the shape of the path, what is the path travel. You look at the time taken between initial until final position. So in this case, what can we do? All right, so we still have a u, a, s, and now we know the v is negative 10. So basically, you can apply any equations to find t. So what is t? So let's say I have a u, a, s, and then I want to find t. So s equals to ut plus 1 over 2 at squared. Then you do the substitution, and eventually you're going to get t equals to 2.04 second. Okay, t equals to 0.24 second. So make sure you do the substitution, because substitution is worth 1 mark. All right, substitution 1 marks, final answer 1 marks. And then for questions, first part of the question, final velocity, usually these questions, it also worth 2 marks if you understand the concept. Okay, if you explain it at s equals to 0, v and u, they have the same magnitude but opposite direction, that 1 marks, and then you state the answer, also 1 mark. So if you use calculations, again, substitution 1 mark, final answer 1 mark. Actually, it's the same. Okay, so you have 2 methods to solve this question, first part of the questions. So this one, I give you 2 minutes to write it down, okay, because this question is very important. It involves concept. So make sure you understand it. If you have any questions, you may ask. All right, 2 minutes for you to write down the notes, the part that you think is important, and then the keywords in these questions and so on.
Madam,
Yes?
why the displacement is 0 meter?
Well, if you remember, what is the definitions for displacement? It is the shortest distance between initial and final position. Now you throw something at this level. Okay, this is the initial position. So it starts from the ground. This is our ground. So it starts from the ground and then it goes back to the ground. So it goes back to its original position. Therefore, the shortest distance between initial and final position is 0. Because it starts at point A, it ends at point A. So the initial and the final positions, they are overlapping with each other. So there's no distance between them, no length between them. So is that okay?
Okay, madam, thank you.
All right, good. Okay, so if no questions, let us move to a next one. So next one, I will just give you some guidance. I won't give you a complete answer, all right? I will tell you how to find informations for every single sub question. Then you yourself are going to solve it. All right. So questions 5. Okay. A ball is thrown from the top of a building and is given an initial velocity of 10 meters per second. So it starts from point A, and at point A, you have a velocity which is equals to positive 10 meters per second. How do I know it's positive? Because you throw upward. The building is 30 meters high. Okay, building is 30 meters high, and the ball just misses the edge of the roof on its way down, as shown in the figure. So basically, this one, the reasons why it mentions the ball just misses the edge of the roof is because it wants you to treat it as a free fall motion, as a vertical motion. So basically what happened is you throw it from A to B, it goes upwards, and then it goes back down along the same path. All right, it just slightly sang a little bit, and then it drops to the ground. So in this case, we are going to treat it as a one-dimensional questions, not projectile motion. All right, just a vertical motion, not projectile motion. So the ball just misses the edge of the roof on its way down, as shown in figure. Calculate the maximum height of the stone. So questions A, it asks us to calculate the maximum height again. Okay, the maximum height of the stone from point A. So initial point is point A, and then the final position is actually your point B. Okay, final position is your point B. So how are we going to solve this question? If you look at the questions, before we solve the questions, the information that we have is u equals to 10 meters per second. Okay, because our initial position is point A. And then this is a free fall motion. So free fall motions, again, we have A equals to negative 9.81 ms negative 2. Now, if you look at questions A, the key words again is maximum. So what happened at maximum, which is point B? So at maximum, object will stop for a moment before it changes its path. Therefore, we can assume V equals to 0 ms negative 1. Okay, so questions A, we have also V equals to 0 ms negative 1. So now that you have 3 known variable, and the question is asking for maximum height, which is S, unknown, so you can solve it now. Okay, you have enough information. 3 known variable with an unknown. 4 variables. 4 variables is enough for you to choose which equations to use. Okay, so questions B. The time taken from point A to point C. So now point A is still your initial position, and point C is your final position. So if you recall, what have we learned in our previous question? Okay, point A and point C, they are located at the same level, same height. So which means at point C, Sy again is equals to 0. Okay, Sy means a vertical displacement. And then your V, okay, your Vy, or you call it V, is equals to negative 10 meters per second. So how do I know that it's negative 10? Because my Sy is equals to 0. So Sy equals to 0, A and C, they have the same magnitude in terms of a velocity, but then they are traveling towards opposite direction. Therefore, for questions B, okay, the information that I have, initial point is still A, so we have U equals to 10 meters per second. And then we have A equals to negative 9.81 ms negative 2. And then what do we have again? Point C, we have S. S equals to 0 meter. And we also have V. Basically, we have more than enough information to solve this question. Now you have all 4 variables, and you want to find the last one, which is the unknown. So basically, you can apply any of the equation. All right? So out of that 4 linear equations, you can choose either one to solve questions B. Now, how about question C? Question C, the time taken from point A to point D now. So from point A to point D, now what are we going to do? We have initial position, again is point A, therefore U is still equals to 10 meters per second. Now, remember, you cannot use U equals to negative 10. Why? Because you still throw the object upwards, even though now our final position is D. But initially, the object is going up. All right, so remember, you don't change the directions of the initial motion. Okay, initial position. Initially, you throw the object upwards. So even though now D is located, okay, your D is located at somewhere below A, but initially the object is still going up. So U is still a positive value. So we have U equals to positive 10, A equals to negative 9.81, MS negative 2. And then what else do we have? Well, we have S. So remember, what did I just say? So displacement refers to the shortest distance between initial and final. So now my initial is point A, my final position is point B. So the distance between the displacement between initial and final is 30 meter. But now if you look at the questions again, final is D, and this D is located below original position, below initial position. Therefore, my S is now equals to negative 30 meter. All right, negative 30 meter. So you don't go and find the maximum height and so on to solve these questions. No need. Okay, no need. What you need is the distance or the displacement between initial and final position, which in this case is equals to negative 30 meter because your final position D is located below initial position. So now that you have S, you have A, you have U, you can then find T, right? You can then find T. So questions D is also the same. Questions D is still point D is your final position. So calculate the velocity when it reaches point D. Okay, so at point D, what happened? Now this is your object. So the velocity of object is still going down. So your V should be a negative. Okay, negative V. So D, you have U equals to 10 meter per second. A equals to negative 9.81, MS negative 2. S is equals to negative 30 meter, okay, because we have same initial and same final position. Initial is A, final is D. So basically, you can use this set of information from question C. So C and D, actually, they are the same, okay? They refers to the same situations. So from here, you can then calculate V. And remember, your V must be a negative value because at point D, the motions of the object is going downwards, okay? It's heading downwards. So now I give you all this information, okay, and I will give you 5 minutes to solve all 4 questions. See whether you can get the correct answer or not. Okay, 5 minutes for you to try these 4 questions. So if you have any questions, you may ask before we proceed to a more complicated situation, which is projectile questions, okay, projectile motion. So make sure you understand all this. Right, so 5 minutes from now for you to solve all 4 of them. So you try to think which equations to use. How are you going to select the correct equations? And then use calculator to calculate the final answer, to press the final answer. So, okay, any questions regarding the vertical motions? Or you need more time to solve this question?
Done, madam.
Done. So very simple, right? So as long as you know the technique, how to extract the data from the questions and how to choose equations. Actually, chapter 2 is quite easy. Okay. So done. And if no other questions, then I will proceed to projectile motion. Okay, we will do projectile motions now. Okay. Okay, projectile motion is a two-dimensional motions. So if it's 2D, means you have to resolve everything into X and Y component. So that's why if you look at your notes, they give you a table here. Okay, it's a guidance actually. It tells you how to solve projectile motions questions. But usually I won't do such a complicated table where you have to write U, V, A, S, T twice. Okay, usually I will just combine it into one. So the car drive straight off the edge of a cliff that is 57 meter high. So it tells you this one is 57 meter high. Okay. And then the investigator at the scene of the accident notes that the point of impact is 30 meters from the base of the cliff. So just now you have 57 meter, which belongs to height. And now this 130 meter is from the base of a cliff. So it represents your SX. So from here until here, this is 130 meter. How fast was the car traveling when it went over the cliff? So what does it mean? So the question is asking for initial velocity. Okay, the question is asking for initial velocity because it wants the velocity when it went over the cliff. Okay, so if you look at the question, it say how fast. Okay, how fast mean it's asking for velocity, but then it doesn't mention whether it wants a vertical or a horizontal velocity. So if the question just mentions a speed or velocity, then it means it is asking for the resultant value. Okay, it is asking for the resultant value. But for this case, even if you don't calculate resultant, you might still get a correct answer. Why? Now let's go back to the diagram. So if you look at the diagram, now we know that the directions of motion, which is the directions of velocity, is the tangents to the curve. So initially your car is moving horizontally. So the initial direction, the directions at the moment when it leaves the cliff is going to the right. So this case, this example is actually belongs to horizontal projectile motion. Okay, it belongs to horizontal projectile motion. So initially you have a U, and this U is straight away equals to your UX. Okay, it's straight away equals to your UX. And then how about UY? Now, because your object is moving towards the right-hand side, it's moving along just the X component, therefore, we know UY is equals to 0. Okay, UY is equals to 0. So UX is the values that we want, and then UY is equals to 0. Okay, so UX is an unknown. So let's write down as UX because we don't know the value. Okay, because we don't know the value. But then what we do know is UY equals to 0. Because of what? Because this is a horizontal projectile motion. Because your object is traveling horizontally at the moment it leaves the cliff. So your U equals to UX at its initial position. Okay, at the moment this projectile motion start. Okay, next. Okay, before we solve the questions, what else do we have? The things that we don't even need to read the questions, we don't even look at the questions and we can fill it in already is the acceleration. if you still remember, in a lecture, we mentioned for x component, the assumptions that we made is object is always moving with constant velocity, because we assume there is no air resistance. So in which it means ax is always equals to 0. And for ay, okay, because we assume object is moving solely under the influence of gravity, so it's moving with constant acceleration. Okay, acceleration. So horizontal, no gravity, okay, and then no air resistance, so it's moving with constant velocity. Vertically, it's moving under the gravitational pull, gravitational force. Therefore, it's moving with constant acceleration. So ay is negative 9.81 ms negative 2. Right? So basically, x component, we treat it as a horizontal linear motion. Y component, we solve it by using the methods, the ways that we use to solve vertical linear motion. Okay, what else do we have? Look at the questions, the things that I highlight. It says the car drives straight off the edge of a cliff that is 57 meter high. Okay, so the height of the cliff is 57 meter, and this height is located below the original position. Therefore, our SY is negative 57 meter. Okay, negative 57 meter. And then for x component, how are we going to solve x component? If you look at the questions again, the things that I highlight, it is 130 meter from the base of the cliff. So the horizontal displacement is 130 meter. Okay, 130 meter. Okay, done. No more, okay, we don't have a V, nothing, no more information that can be added into the table. We don't have time, we don't have V. And the question asks us to count what? To calculate UX. Now, can we calculate UX? So before that, let's look at the information. Okay, in order to calculate UX, we need to use the information along in the x component. Okay, the information in the x component. So x component, we have one known variable, two known variable, and then just UX. And we cannot solve it because we don't have enough information. And if you recall, what did I told you in our lecture? For x component, actually we have only one equation, which is Sx equals to uxt. So in order to calculate ux, what do you need? You need Sx, well, we have, and you need time, but we don't have time. Time is an unknown. What can we do? Now, in a projectile motion, u, v, a, and s, they are all vector. The only non-vector is time. So means time can be shared between y component and x component. It is a scalar quantity. Okay, so this is a scalar quantity. So you can use the time for from y component for x component. Okay, but for the other four variable, they are vector. So you cannot mix them. Kamu tak boleh campur. Okay, you cannot mix x and y component in one equation. So if you want to solve, you want to calculate the information for the x component, then everything must be from x component. If you want to calculate the information for y component, then everything must be from y component, except for time. Time can be used for both of them, right? In which it makes sense. All right, it makes sense because time is a scalar quantity. It doesn't matter what is the direction, whether it moves horizontally or it moves vertically. It's going to take same amount of time to reach that final position. So ux equals to sx over t, and now we don't have t. But we know that we can use t from y component because it is a shared variable. So let's see, can we calculate t from y component? Now you have a uy, you have ay, and you have sy. Yes, you do have enough information. You have three known variable, and now you want to calculate this one unknown variable. So for y component, now let us recall the four equation. So y component, because of constant acceleration, you can apply the four linear equation, which is a sy equals to uyt plus 1 over 2 ayt square, sy equals to 1 over 2 uy plus vyt, and then vy equals to uy plus ay t, and the last one vy squared equals to u squared plus 2as. So you have these four equations that can be used for y component. So for x component, you have only one equation. So this is your x component, constant v, so you have one equations only. And then for y component, okay, for y component, you have a constant acceleration. Okay, not nice, this color. So you have constant acceleration. Therefore, what can you do? Let's see this one. So a constant. No, one highlight. Okay, this one. Okay, so you have constant acceleration in which you have four equations to use. So you can choose from these four equations. All right, you can choose from these four equations. So now which equations am I going to use? I have u, I have a, I have s, and I want to find t. So which means I'm going to use a first equation. Okay, so by using sy equals to uyt plus 1 over 2 ayt square. Okay, so sy is negative 57 equals to, okay, negative 57 equals to u is 0. So 0 t plus 1 over 2 negative 9.81 t squared. Right? So the time taken, t is equals to 3.41 second. So now that you have the time, okay, which is 3.41 second, and this time we know it's the same for both x and y component. So 3.41 second, 3.41 second. I add it into the table. And now from the table, you can then calculate ux. Okay, so ux is equals to 130 meter divided by time, which is a 3.41 second. So ux is a 38.1 ms negative 1. Okay, so 38.1 meter per second. So that is the final answer. Okay, that is the final answer. And that is how we solve a projectile motions. The table is very important. So from the table, you know, okay, what is the information that we have? Do we have enough information to apply the equations? So if no, then what can we do? Can we get the information from the other component? If can, then okay. If not, then what can we do? So try to think from there. So that is the technique in answering questions. All right, by looking at the table. So table asks you to calculate. The question asks you to calculate ux. So you don't have ux. So what can you do? The equations that you can use is ux equals to sx over t. But then you don't have t. So from the table, again, you try to check if you can get t from the, see if you can get t from the y component or not. So obviously you can, then you calculate t, and then it goes back to x component. All right. So that's why we encourage students to use table. So I got student asked me before, if I don't want to use table, can or cannot? Yes, you can. All right, table is just a tools. We say a tools to help you to organize the data in a more neat way. Okay, in a more tidy way. So if you don't want to use table, it's up to you. All right, tak ada paksaan, tak wajib. Okay, jadual tak wajib. So dalam exam tak nak jadual ini terpulang pada anda. Cuma jadual ini membantu anda tengok data dengan lebih kemas. Alright, dengan lebih kemas. So now I give you 3 minutes. Okay, 3 minutes to write it down and then to write down the notes, how to solve the questions and so on. So if you have any questions, you may ask before we proceed to next question.
Madam,
Yes?
I have a question.
Yes.
In all type of scenarios, the time for x component is always same to the time in y component, is it?
Yep.
Always.
Always, because time is a scalar quantity. You try to imagine. Now you have a car. This car want to go, let's say, until point A. Okay? So takkan, it takes 5 seconds to drop from here to point A, the displacement here, but then it takes 20 seconds to reach here. It can't be two different time, right? So X and Y, they always take the same amount of time to reach the same position.
All right, clear.
All right. Okay. Okay lah. So 3 minutes for you to write it down and see which part of it you don't understand, then you can ask. Okay. Next question. Okay. Where's my arrow? Okay. So questions 2 is also very similar to questions 1. A transport plane traveling at a constant velocity. So what do we have? We have a constant velocity. Okay. So constant velocity, 50 meter per second at an altitude of 300 meter. Release the parcel when it is directly above point X on a level ground. So actually there is a point X in the question. Okay, so this is your ground and then this is your point X. Okay, so calculate the flight time. So the flight times of the parcel, the time taken, and then the velocity of the impact. Okay, so flight time, simple. So a velocity. Now, if you look at this question, it just mentions velocity without telling you whether it's x-axis or y-axis. So in which it means you need to calculate its resultant velocity. All right, and then the last one is the distance from point X. So distance from point X refers to what? It refers to the range, Sx. So this is your V total, and then this is your time. So let us complete the table. Okay, let us complete the table. So this, according to the diagram, now you have a horizontal projectile motion. Okay, so the plane is traveling horizontally. So in this case, we have U equals to Ux. Okay, which is equals to 50 meter per second. Now you don't have to put a negative sign here, even though the diagram showing to the left, because for horizontal motion, it's up to you to choose whether right-hand side or left-hand side is a positive direction. And usually we take the directions of motion as a positive direction. Okay, so U equals to Ux equals to 50 meter per second. So Ux, we have 50 meter per second. So in this case, what do we have for Uy? 0. okay, 0. And Vx, Vy, okay, Vx we have. Why? Because we say x component is moving with constant velocity. So what does it mean by constant velocity? Constant velocity means Vx equals to Ux. So our Vx is also 50 meter per second. Ax always 0. Sx, well, Sx we don't have because that is what questions 1, C. And then Vy, do we have Vy? No. And then do we have Ay? Yes, negative 9.81. So A, you can always fill in the value without looking at the questions, okay, because the value is fixed. And then Sy, so do we have Sy? Yes, because it tells you now the flight is 300 meter above point X. So now 300 meter above point X. So if you look at the diagram, this 300 meter once again is located below the object, below the plane. Therefore, it is negative 300. Okay, negative 300. All right, now let's see how are we going to solve the questions. Questions A asking for time. Okay, it asking for time. So if you look at X component, do you have enough information to calculate time? No, because for X component, the only equations that we have is S equals to UT, okay, for X component. So obviously, we cannot calculate time by using X component because we don't have Sx, all right? So we don't have Sx, so we cannot use it. Then how about Y component? So you have a U, you have A, you have S. Yes, you do have enough known variables. So now you have 3 known variables and you want to calculate this unknown variable. Which equations are we going to use? So UAST. So SY equals to UYT plus 1 over 2 AYT squared. So that is how you solve it for questions A. So SY negative 300 equals to 0t plus 1 over 2 negative 9.81 t squared. So rearrange the equations. You are going to get t equals to 7.82 second. Okay, so now you have t equals to 7.82 second. You can then put it in the table. So 7.82 second and 7.82 second. Right? And then questions B. So question B asking for velocity. So like I told you just now, because the questions doesn't mention whether it's a vertical or a horizontal velocity. Therefore, it's asking for resultant velocity. Okay, so it wants resultant value. So what does it mean by it wants resultant value? So resultant V is equals to square root Vx squared plus Vy squared. So let's go back to the table again. So do we have enough information? Obviously no. Okay, because we have only Vx, but we don't have Vy. So what can we do? We can calculate Vy. Do we have enough information? Yes, we do. So Uy, Ay, Sy, and you have T as well. All right, so let's say we are going to use Vy. Okay, we're going to use a UAS. So Vy square equals to Uy square plus 2AySy. Right? So the reason why I choose these equations, I will tell you after this. So Vy equals to 0 plus 2 negative 9.81 and a negative 300. So negative, eventually it becomes positive value, right? And then V, you have Vy equals to 76.71 meter per second. But this is a plus minus value. All right, so which value are you going to choose? Positive or negative? Now let's go back to the diagram. This is a final position, okay? And we know the directions of motion is the tangents to the curve. All right, so from this dot, you draw a straight line. So this is the directions of V. If this is the directions of V, when you resolve it into X and Y component, Vx and Vy, what is the directions of Vy? Vy is downward. So in this case, it means our Vy should be a negative value. So negative 76.71 ms negative 1. Right? So now that you have Vy, you can then proceed to the resultant value. So givens in the table, Vx equals to 50 meter per second. So you are going to calculate V equals to square root 50 square plus negative 76.71 square. So which is equals to, okay, the answer is a 91.57 ms negative 1. Now let's go back to the questions again. Questions say velocity. Velocity, it is a vector. So which means other than the magnitude, okay, this is what we call magnitude. So the value, we call it magnitude. So now we need the direction because questions mentions velocity. If the questions mention speed, then that is the final answer. Okay, your 91.57 is the final answer. But now questions mentions velocity. So you need to add one more step to calculate the direction. Okay, you need the direction. So how to calculate direction? Same as the method that you use to calculate the resultant vector. So tangent theta equals to Vy over Vx. So I put a modulus here. And then theta equals to tangent negative 1 negative 76.71 over 50. All right. And then the angle is 56.9 degree. So where is this 56.9 degree? Below negative x-axis based on my diagram. All right, based on the diagram, this is our resultant vector. So this is the angle. Okay, so this is how you solve questions B. Okay, let me zoom. All right. Okay. So question C, okay? Question C asks you to calculate Sx. So Sx is very simple now. So now that you have a time, you have a Ux. So Sx is straight away equals to Ux times T. Okay, so the answer is 391 meter. That's it. All right, so the answer is 391 meter. Okay, so now you can solve these questions. Okay, you can write it down, especially for questions B. So questions B is a very common sense questions, and students tend to panic because they don't know whether they need to find the V for the X component or for the Y component. So in this case, because the questions didn't mention whether it wants a horizontal or a vertical velocity, then you need to find the resultant velocity. Okay, you need to find the resultant velocity. Okay. So I give you 3 minutes to write it down, especially for questions B. Now, can you see the answer? Or do I need to zoom it in?
It's okay, madam.
It's okay, right? Okay, good.
Madam, for question B,
Yes?
why do you have to find the resultant?
Because the questions didn't tell you. It wants a horizontal or vertical. It just mentioned velocity. So if the question just mentions velocity, means that it is asking for resultant. Okay?
Oh, okay, madam. Thank you.
So unless the question say, okay, now calculate the horizontal component of the velocity, then you need to find Vx. If the question say vertical component of the velocity, then you need to find Vy. So if just velocity or it mentions calculate the speed, then it is asking for resultant.
Madam,
Yes?
question.
Yep.
Okay, ux is always equals to vx, is it? In all scenarios?
Yes.
Okay.
Okay,
Okay.
because we assume there's no air resistance. So if no air resistance, for horizontal motion, object will always move with constant velocity. So constant velocity means it doesn't matter at which position, the velocity will be the same.
Okay, thank you.
Madam,
Yes?
if we don't do the direction, we will lose the mark.
For which questions?
For velocity question.
Yes, you'll lose 1 mark. So usually the questions like this, okay, the Vy is a 1 mark, and then Vx 1 mark, V resultant 1 mark, direction 1 mark. 4 marks question. Okay, so usually your Vy is 1 mark, and then the Vx 1 mark. Sometimes they will give the substitution, sometimes they don't give the substitution, but this 91.57 definitely 1 mark, and then the direction is 1 mark. Okay, the direction is 1 mark. 4 marks question. Okay. So any other questions? If no, we'll proceed to the next one. Questions 3. So questions 3, the types of the questions is different than the previous one already. Let's see how to solve this question. Questions 3, a football is kicked at an angle. Okay, so now you have a football is kicked at an angle 37 degree with a velocity. Now again, question just tells you velocity. It didn't mention whether it's a resultant, it's a vertical component or a horizontal component. So which means this V is the resultant velocity. Okay, because the questions didn't say this velocity belongs to horizontal or component. It just mentions velocity. So in that case, it refers to resultant. So as shown in a figure below. So you have a figure, it tells you this 37.0 degree. Okay, and then you have a U. According to the question, U is equals to 20 meter per second. So questions A, calculate the maximum height. Okay, the questions A, maximum height. Now, for these questions, you are going to use 2 different tables. Okay, 1 table for maximum height and 1 table for final position. So obviously, questions A, you need the table for maximum height. Okay, you need a table for maximum height. So let us do a table first. So this is a table. Okay, so vector, x component, y component. So yeah, done. So we have a x, we have a y, and then a u, v, a, s, t. So initial velocity, do we have it? Yes. Now you have u here, and then this is 37 degrees. So basically, you can resolve it. All right, so this is your u, which is equals to 20 meter per second. And then this is the angle, 37 degree. You can resolve it into ux and uy. Okay, ux and uy. So ux is equals to 20 cos 37 degree. And then uy is 20 sine 37 degree. So both of them, they are positive value, okay, because ux is going to the right and uy is going up. And then for v, now vx, we can fill it in. So vx is still 20 cos 37 degree because constant velocity. Okay, velocity is always constant along x component. And then y, for y component now. For y component, do we have v? Yes, because question tells you maximum height. So what happens along the vertical component if object is located at a maximum height? If object reaches maximum height? Well, at maximum height, Vy is 0. Therefore, in the table for V along Y component, it is 0. So Vx is not 0, but Vy is 0. Why? Because at this position, your V is going to the right. Okay, the tangent of the curve. So it forms 90 degree to the radius. So tangents of the curve, this is your V, and it is equals to Vx. So Vy is equals to 0. Okay, so V at maximum position, it does not equals to 0. Only the vertical component of the final velocity, okay, of the velocity at maximum height is equals to 0. So don't get confused, all right? Don't get confused. So I'm going to write it down. So at max height, okay, at max height, V is not equals to 0, right? V is equals to Vx. So only vertical component of V, okay, which is a Vy, it is equals to 0. So make sure you know, okay, this is a very tricky questions in objective questions. So it might come out in your UPS, who knows? So make sure you understand. V, you got 3 different V. You got horizontal component V, vertical component V, and resultant V. So at max height, resultant, it does not equal to 0. Only vertical component is equal to 0. Okay, so now, yes?
The V equals to Vx is in terms of horizontal component, is it?
It's at maximum height only. So at maximum height, V is the resultant, is equals to Vx horizontal component.
Meaning?
Hmm?
Meaning? What does it mean?
Can you repeat your questions again?
Okay, I don't understand the fact that why is it V equals to Vx at maximum height? Are you talking about a horizontal component or what?
No, I'm talking about the resultant. This V refers to resultant. Now, the directions of motions, the resultant value at every position is actually the tangents of the curve. First of all, you need to understand what does it mean by tangents of the curve. So for example, if you have a circle, tangents of the curve means that this line, this tangent line, it always forms 90 degree to the radius. So this is your radius, this is a tangent, okay, tangent, and then it always forms 90 degree. So it doesn't matter which positions you're looking at, you can look at here. So if this is a tangent line, okay, so what does it mean by tangent? Tangents mean it forms 90 degree. So it's again 90 degree. So in this case, the directions of motion at this curve at the maximum height, it happens to be a horizontal. Okay, it happens to be pointing to the right. It forms 90 degree to the radius. So this h actually is the radius of the circle, of the curve. So this resultant, these directions of motion at this moment, okay, is perpendicular to the h, to the height. Therefore, resultant is just equal to Vx. Vy is equal to 0. If you look at different position, let's say you look at here. So at this point, the directions of motion, again, is the tangents of the curve. Okay, I'm going to say this is a tangent. Okay, this is a tangent. So direction will be headings towards here. This is the resultant. Now at this position, because the resultant is lying in between x and y component, therefore my Vx and Vy, both of them, they are not equal to 0. This is Vy, this is Vx. But at this maximum height, the tangent of the curves happen to be this horizontal line. Okay, it happens to be this horizontal line. Therefore, I say my v, okay, my v resultant vector is equals to horizontal component. It's just because now the tangent is a horizontal line. So at different positions, the tangent is different. The directions of motion changes. Okay, just like the circle. So if you have an object, okay, now let's say if you have a ball traveling in a circular motion, so the directions of this ball is changing with time. So at this position, the directions of the ball is heading here. Okay, and then at this position, the directions of the ball is now pointing here. Okay, because this is a tangent. It forms a tangent with the circle. We use a tangent line of the circle. So 90 degree. 90 degree to the curve. So in a projectile motion just now, what happened? So we have a curve like this. Okay, so this is a curve. So at maximum height, the tangent line is a horizontal line. Okay, the tangent line. So which means my object at this position is actually heading to the right, just at this moment. Okay, just at this moment, this is the directions of motion. Okay, directions of motion. So in which it means the value that is pointing towards this direction represent resultant value. Therefore, our V at this position at maximum height is equals to Vx. Okay, V equals to Vx. Just because now the directions of motion is lying on the x component. If it move a little bit, okay, then the directions will change. So let's say now it drops a little bit. So now the directions of motions maybe is slightly sengit. Okay, and this is no longer, V is no longer equals to Vx. So now this V, you have to calculate the resultant. It's equals to Vx squared plus Vy squared. So this is the directions of V now. So it's no longer lying on the x component or y component. Therefore, you cannot assume V equals to Vx.
Okay, clear. So whenever it sits on like in a horizontal line, so we always assume that V equals to Vx since it's in
Yes.
the horizontal component.
Yeah.
Whereas there's no, motion vertically, so we assume that Vy equals 0. So this is how it works.
Yep.
Okay, clear.
Okay. All right, so now let's go back to the table. So we are done with V. So since the motion is lying on the x component, we know that V equals to Vx and Vy equals to 0. And A, okay, now let's see A. So A again, because the horizontal component is a constant V, so we have a 0 here. And then Y component is always negative 9.81. So basically, this table is a combination of the things that we learned in exercise 2 and exercise 3. Just that now we split them into two components, and then when we want to calculate resultant, we combine them together. And it will give you information, a curve, a projectile motions curve. Now, how about S? Do we have information about S? I think no. All right, yeah, there's no information about S. So S, we're going to leave it. And then times also, we don't have the time. So question asks you to calculate maximum height. So maximum height means Sy. Okay, maximum height represent Sy. So Sy equals to unknown. So now do we have enough information to calculate Sy? Obviously, we have. So if you look at the questions, now you want to calculate Sy, means that you can only use the information from Y component. So for Y component, we have U, we have V, we have A, and now we want to calculate S. Therefore, Vy squared equals to Uy squared plus 2Ay Sy. So V is 0. 0 equals to 20 sine 30 degree. Make sure your calculator is in mode degree. And then plus 2, negative 9.81. And then Sy is the things that we want to calculate. Okay. So Sy, the final answer is, let me see. Final answer, Sy, 7.39 meter. Okay, so Sy is equals to 7.39 meter. So that is questions A. Okay, questions A. So the important thing in question A is the final velocity. Okay, at maximum height, Vy is equals to 0. All right, now let's look at questions B. The times of travel before the football hits the ground. Now, for questions B, can we use the information from a table from questions A? Yes, you can. Okay, because if you have a if you have a projectile motion where it starts from ground and then it ends on the ground, same level, okay, the same level, then the time taken to reach maximum height and the time taken from maximum height to reach the ground, they are equal. Okay, so you can still use the table from questions A if you want. Okay, if you don't want, I will show you the second method after this. So if you use the informations from questions A, okay, so we use a y component again because we only have enough information for the y component. So you have a u, v, s. You want to calculate t. So s y equals to u y t plus 1 over 2 a y t squared. Right? And then sy, I don't have s, right? Sorry, I choose the wrong equations. So I have uva. I want to find t. So vy equals to uy plus ayt. So v is 0 equals to 20 sine 30 degree plus negative 9.81 t. So the t that you obtain is equals to the t that you got is equals to 2.4, 1.22 if I'm not mistaken. Yes, I think it's equals to 1.22 seconds. So this is the time taken to reach maximum height. Okay, this is the time taken to reach maximum height. You haven't calculated the final answer yet. Okay, you haven't calculated the final answer yet. So remember, don't stop at here. You need to continue. Okay, you need to continue. So the time travel, if you look at the questions, it wants the time travel before it hits the ground. Okay, so the times travel is equals to, times travel is equals to 2t, which is equals to 2.44 seconds, right? Which is equals to 2.44 seconds. So remember, if you use the first table, then the times that you calculate is the time taken to reach maximum height only. And if the object goes back to the same level as its initial position, so you start from ground, it goes back to ground, then the times travel, you just times 2. If it doesn't go back to ground, then you cannot use this method anymore. All right, you cannot use this method anymore. Now, the second method that you can use is you form another table. Okay, another table for 0 and point P. So table for questions A, table for question A is only a table for maximum height. All right, table for maximum height. Now, questions B, what if I want to assume my object goes back to ground? So what can I do? So if it goes back to ground, I'm going to form another table. Okay, I'm going to form another table. So X component, Y component, and then U, V, A, S, T. I have U because I have the same initial position. I didn't change the initial position. The final position, the only thing that I changed is the final position. From maximum height, go to ground. So this is ground. Okay, just now it's for maximum height. So 20 cos 37 is still the same. A is still 0. And then U, well, same initial velocity. Now I don't have V. Okay, V is no longer equals to 0. What do we have when an object reaches the ground? We have, okay, this is negative 9.81. We have Sy. Sy is equals to 0. Okay, Sy is equals to 0 because now your object goes back to the ground. So the displacement along vertical component is 0. All right, it's a 0. So now that you have this table, straight away you can apply Sy equals to Uyt plus 1 over 2 Ayt squared to find out t. So if you use this table and these equations, then t is straight away equals to 2.45 seconds. All right? So this is a second method. So just now is method 1. Wait, yeah. So we have a method 1. So this is method 1. Okay, so method 1, you calculate time taken to reach maximum height. And then times 2. Okay, and then the method number 2, this is your method number 2. So straight away you calculate the time taken to reach ground. Okay, this is information is for ground. So you don't need to times 2 anymore. All right, you don't need to times 2 anymore. That's why I say you might need 2 different tables. Okay, because one of them is for maximum height and another one is for ground. Okay, so if you take it reach the ground, then your S is 0 for Y component. So that is the main difference between these 2 tables. All right, that is the main difference between these 2 tables. So, well, I let you copy it first. Okay, I let you copy it first before I proceed to questions C, D, and E. Right, kamu catat dulu sebelum kamu lost. So kamu fahamkan dia dulu kenapa saya ada 2 jadual, and then kamu cuba fahamkan apa beza antara 2 jadual ini. Okay, macam mana nak buat first 2 question before I proceed to questions D, E, and D, E, C, D, E. Okay, so 3 minutes for you to write it down because I have 3 pieces of information. Questions A, and then questions B method 1, questions B method 2.
Madam,
Yes,
dekat UI component,
yes.
macam mana dapat 20 sin 30 degree bukan ke 37?
Ayah, saya typing error begitu banyak kali. Tak ada orang beritahu saya pun. Okay, sorry, my bad. It's 37. Okay, 37. Thank you.
Madam, for this question, the initial velocity and the final velocity is the same, right?
For which one?
Like from the graph,
Yes.
U is 20 meter per second. And then when it reached the ground at the P point, the velocity is going to be negative 20 meter per second.
It's still 20 meter per second. You cannot say negative. You have to describe the position because a resultant vector, if you say negative, then it's negative for which component? We don't know. So you can say 20 meter per second, but now it's below positive x-axis.
Oh, okay, thank you.
All right. So that's it. So now question C. Okay, question C is very simple. How far away hits the ground? So it's asking for Sx. So if you got a T from questions B, then you know that Sx is always equals to Uxt. Okay, so you can then calculate Sx. So question C, right, C. So Sx is equals to Uxt. So this T must be coming from questions 2. All right, must be coming from questions 2. So Ux is 20 cos 37 degree, and then the time is 2.45. Straight away you got the answer, which is equals to 39.1 meter. Okay, 39.1 meter. Questions D and questions E, okay, is it want to test your concept actually. So what is the velocity vector at maximum height? So that is the things that I explained it to you just now. Velocity vectors means it's asking for Vx and Vy. Okay, it's asking for Vx and Vy. So Vx is equals to the V. Okay, is equals to your Ux, which is equals to 20 cos 37 degree. So Vx equals to Ux equals to 20 cos 37 degree. So you calculate the answer. And then Vy, like I told you just now, at maximum height, Vy is equals to 0. Okay, Vy is equals to 0. So maximum height. So maximum height, you have only this one, horizontal component. Then how about accelerations vector? So accelerations vector is very simple. Ax and Ay is a fixed value. You don't even have to think. Okay, you don't even have to think. So for questions E, Ax is always equals to 0. Ay is always equals to negative 9.81, regardless of its position. Okay, regardless of its position. So Ax and Ay, straight away you can get it from table. So tak kisah objek kamu di mana, Ax and Ay is always the same. So that is the meanings of velocity vector and acceleration vector. It's asking for the x component and also the y component. Right, so you write it down. Question C, D, E is very simple. Okay, just that D and E, you need to know what is the value along the x component and along the y component. That's it. So kalau kamu dah faham apa yang saya terang tadi, actually questions D sepatutnya boleh faham juga. Kenapa satu kosong, kenapa satu bukan kosong at maximum height. Alright. So 1 minute for you to write it down. Okay, CDE, very simple. Then we're going to proceed to a questions 4. Questions 4 is much easier compared to questions 3. So, ada siapa lagi? Ada masalah, ada pertanyaan, nak tanya? Pastikan anda faham sebab biasanya soalan projectile motion sangat banyak markah. Okay, sangat banyak markah. No question. No questions means questions 4. Okay, so questions 4, you are going to need to draw a diagram. Okay, why? It tells you a ball is thrown from a point 1 meter above the ground. And the initial velocity is 20 meter per second at an angle 40 degree above horizontal. So you need to draw a diagram first, okay, for this given situation. So you have a building, let's say. So this is the ground. So building is 1 meter tall. And then initial velocity is 40 degree above horizontal. So you need a horizontal line. This is not the projectile motions here. Your projectile motion is like this. So this is your 40 degree. So this is your projectile motion. All right, this is your projectile motion. So just now it's just a horizontal line. So this is the diagram for questions 4. So find the maximum height of the ball above the ground. So this is once again a very tricky question. Okay, it's not just a maximum height that it wants a maximum height above the ground. So what are we going to do? As usual, I would like to form a table. So questions A, table for questions A, which is a table for maximum height. Okay, table for maximum height. So x component, y component, u, v, a, s, t. So a, I don't even have to think, is 0 and negative 9.81. So what else do I have? Let's see. Okay. So initial velocity is 20 meter per second at an angle 40 degree. So now you have an angle 40 degree. So u is equals to 20 meter per second. All right. So u 20 cos 40 degree, and y component is 20 sine 40 degree. Vx, well, x component, v constant, so same value, 20 cos 40 degree. Vy, we don't have it. And then Sx, do we have it? No, we don't have. Sy, do we have Sy now? Try to think, do we have Sy for questions 4? Actually, we don't have. Okay, we don't have Sy. Why? Because now you want to find maximum height. Then we are going to assume this one as our initial level. Okay, this one as our initial level for these questions. So Sy we don't have. So what else do we have? U, we have this one, and then at maximum height, just now I missed out. At maximum height, we do have Vy, which is 0. Okay, because of the term maximum height. So this is 0. Why? Because maximum height. And then S we don't have. Okay, Sx no information. Sy also we don't have. Because now we're taking this as our reference position. So you don't look at this 1 meter. This 1 meter is to trick you. If you put Sy equals to -1, then you won't be able to solve this answer anymore, these questions anymore. Times we also don't have. Okay, so what the questions one now is the maximum height. Let's call it capital letter H. No, I want to call it Sy, make it easier. Okay, so let's call it Sy. So now you want to calculate the values of Sy. Do you have enough informations? Let's see. Table, we have Uy, we have Vy, we have Ay, and we want to calculate Sy. Yes, we do have enough information. So UVAS, so V square equals to Uy square plus 2Ay Sy. So V is 0 equals to 20 sine 40 degrees square plus 2 negative 9.81 and then Sy. So Sy is equals to 8.43 meter. Now, if you leave the answer at 8.43 meter, then you are going to get the wrong answer. Okay, 1 mark will be deducted because you haven't answered the questions yet. The question is asking for the height above the ground. Therefore, you need to write it in statement. The max height of the ball, okay, above the ground is equals to 8.43 meter plus 1 meter, which is equal to 9.43 meter. So this is the final answer. Okay, this is the final answer. So make sure you answer the questions. All right, make sure you answer the questions. Don't stop at 8.43. If you stop at 8.43, 1 mark will be deducted. Right? So questions B, again, it asks you to calculate the speed. Okay, now it's just asking for speed, so you don't need to determine the direction. All right, and then the speed at the highest point. So highest point, again, is the maximum height, which means you don't need to form a new table anymore. You can use the table from questions A because this table is for maximum height. Okay, this table is for maximum height. So calculate the speed of the ball at its highest point. Now you don't even have to calculate anymore. Why? Because you have Vx already. And then you have a Ux. So questions B, speed equals to square root Vx square plus Vy square. Okay, so which is then equals to 15.32 ms negative 1. Done. That is the answer. You don't need to state the directions. Why? Because of speed. Okay, speed is a scalar quantity. So no need direction. Okay, don't need direction. So make sure you understand which term represent vector, which term represents scalar quantity. Okay, if a vector, then you need to state the direction. If a scalar, then you don't need to state direction. If the question is asking for the magnitude, then also you don't have to state the direction. All right. So if you want to state, does it wrong? No. Okay, it's fine. Just that you are going to spend more time in solving the questions. Right, so we're done with these questions. Again, I give you 2 minutes to write it down. If there's anything that you don't understand, you may ask. Okay, so especially the reference position. So make sure you understand why I choose this as a reference position. Okay, so last question. Okay, last questions. Last question is very similar to previous question. Okay, why? Because it tells you now you thrown something, you thrown an apple at an angle 30 degrees above horizontal from the top of a building that is a 20-meter height. And initial speed given is 40 meters per second. So the diagram is similar to the previous question. You have a ground and then you have a building. This building is 20-meter high. Okay, 20-meter high. And then this is the apple. And apples, you throw it at an angle, which is 30 degrees above horizontal. Okay, and then the initial speed is 40 meters per second. So calculate the time taken for the apples to strike the ground. So now it's no longer asking for the maximum height. Okay, it wants the information when apples strike the ground. So how are we going to calculate then? Again, form a table. So form a table for ground. Okay, for the object when it reaches the ground. So X and Y. So U, V, A, S, T. So again, I'm going to fill in A first, 0 and negative 9.1. So according to the questions, I have initial velocity 40 cos 30 degree and 40 sine 30 degree. Vx 40 cos 30 degree. Vy, now I don't have Vy, okay? So if you look at the diagram, when the apple hits the ground, this is the directions of the apple. Okay, this is your V. So your Vx is still going to the right, and then Vy, I don't have the information. So Vx is equals to Ux. Vy is an unknown, so we leave it as unknown. And then how about S? Do we have any information about S? Sx, no. How about Sy? Sy, yes, we do have. So if you recall what we explained, what we discussed in a vertical linear motion, S represents the shortest distance between initial and final position. Your initial position is located at somewhere that is 20 meters from the ground. Your final position is at the ground. It's below the original position. Therefore, it is equals to negative 20 meters because now it is located below, okay, below initial position. Therefore, it's negative 20 meters. And then T, well, we don't have T. And that is the things that we want to calculate. So let's go back to the question. Question asks you to calculate what? It asks you to calculate time taken. Time taken, can we use Sx? No. Why? Because Sx, we have only one equation, Sx equals to uxt. If you want to calculate time, then you need Sx. But now it is an unknown. Therefore, we cannot use x component to solve this question. What we can do, we can use y component to solve it. Because we have enough information. We have u, we have a, we have s. And then question 1 asks us to find t. Therefore, sy equals to uyt plus 1 over 2 ayt squared. Sy negative 20 equals to 40 sine 30 degree t, and then plus 1 over 2 negative 9.81 t squared. Make sure to include negative sign in sy. All right, most of the time students got it wrong because they didn't put a negative sign in the s. So sy is negative 20. It is very important. So t is equals to 4.91 second. Okay, 4.90 or 4.91. Both are accepted. All right, both are accepted. So questions A, now you got 4.91. Therefore, you can sub it into the table. So 4.91 second, 4.91 second. Questions B asks you to calculate the distance from the foot of building when it strikes the ground. Means it is asking for Sx. So from here until here. This is your Sx. And now can you calculate Sx? Yes, you can. Because you have time now. Okay, you have a u, you have a t. Therefore, Sx equals to uxt, which is equals to 40 cos 30 degree times 4.91. Therefore, it is equals to 107 meter. Okay, 107 meter. And then question C. Question C asks you to calculate maximum height. Therefore, you need to change the table a little bit. Okay, you need to change the table a little bit. Or, yeah, I think it will be better if you change the table a bit. So now you make another new table. Okay, so this table is just a very simple table. xy, u, v, a, s, t, 0, negative 9.81. And now this is the table for max height. Okay, this is a table for max height. So u is still the same. 40 cos 30 degree, 40 cos 30 degree, and then 40 sine 30 degree. So the difference between these two tables is now you have information about v. Vy at maximum height is 0. Okay, so this is the main difference between these two tables. So v and s. Okay, so now you cannot use s equals to negative 20 anymore because you don't know. Okay, you don't know what is the s. So this is your sy. So sy now is an unknown value. And then time, can you use 4.91? Cannot. 4.91 is the time taken to reach ground. Now our object is located at the maximum height. Okay, it hasn't reached the ground yet. Therefore, 4.91, you cannot use it for question C as well. Okay, so we don't have the time, we don't have the time. We also don't have Sx, okay, because we don't have the distance from the building until the maximum height. This one is an unknown. All right, therefore, okay, what can we do now? We want to calculate Sy. And when Sy, maximum height, represents a vertical component. So Sy, unknown. So we have a Uy, we have a Vy, and then we have Ay. So again, we use Vy squared equals to Uy squared plus 2Ay Sy. Okay, so rearrange the equations, you will get Sy equals to 20.4 meter. So 20.4 meter, again, is not the final answer yet. Okay, the question is asking for the height from the ground. Therefore, okay, therefore the height from ground, once again, okay, the height, the max height from ground is equals to 20.4 meter plus 20 meter, which is then equals to 40.4 meter. All right. So this blue color part is usually the careless mistake that students make in the exam, because you guys tend to get very excited once you got the SY and you forgot about the question. Question is asking for the height from ground. So remember, you need to add the height from ground, which in this case, it is a 20 meter. Okay, so you add the height from the height of the building. All right, so that's it. Okay, so any questions? So you try to write it down, and if no questions, I think that's all for today. You may leave the class.
Okay, thank you, madam.
All right, cool. Thank you.
madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Okay.
Thank you, madam.